So we just looked at how to find vertical asymptotes, and now we're going to look at how to find horizontal asymptotes. So again, we're going to look at the base case. What happens for 1 over x? So again, you can plug in some values. I think just looking at the graph is probably enough. So 1 over x looks like this. Again, we're looking at what happens as x goes to infinity. So we're going to keep going all the way to the right side of our graph as far as we can, and our graph looks like this. And what's happening? Well, this graph is getting closer and closer to the x-axis. Like if I take 1 over a billion, I'm going to get some really, really small number. And if these numbers just keep getting smaller and smaller, it makes sense that this limit is 0. All right, so when you take a number and divide it by x with really big numbers, you're going to get 0. All right, so I say this a lot, like what's a number divided by a really big number? All right, I'm going to say 0, all right, because it is 1 over x example. All right, polynomials are a little bit different, so instead of having the 1 over, we just have a polynomial. So what happens at infinity? I didn't write these down, but if I just find out the limits at infinity, all right, of x squared and x cubed, you're just plugging in some big positive number, and you're going to get an even big positive number out. So you just get infinity. Well, negative infinity, it doesn't matter if you plug a negative into x squared because the negatives will cancel, you'll still get infinity. But for a cube, there's 3 negatives. 2 of them cancel out and you're still stuck with them. So for x cubed, you're going to get negative infinity. All right, so there's kind of 2 things to recognize here. One is polynomials do not have a horizontal asymptote. All right, they're going to infinity because they just look like this. And that, all right, they never level off. They keep going in the same direction forever. But another thing to recognize is the even powers, the tails, the ends are going the same direction. And for the odd powers, the tails are going in opposite directions. So that's just one thing to keep in mind when you're looking at polynomials and things that can help you figure out what's happening. But now we want to look at an actual rational example. So for right now, most of our horizontal asymptotes are going to have to do with rationals because they actually have a chance of leveling out versus polynomials just go to infinity on either side. All right, so what we're going to do is we're going to do it the long way a couple times, and then we'll figure out the shortcut. But we know how to work with 1 over x. So what I'm going to do is a little weird. I'm going to factor out an x on the top and bottom. At first you might say, well, that's not possible because there's not an x on both terms, and that's kind of true. So I can factor out an x from the 3x and just get a 3. But I can't really factor out an x from a 2 because there's no x there. So what happens when you're factoring something out? Really, you're just dividing that thing away. So this is going to be 2 over x. So if there's no thing to factor out, you just have to divide by it. All right, and this makes sense because if I were to go back and FOIL this back in, or distribute this back in, I'd get x times 3. That's 3x. The x would cancel there, and I'd get 2. All right, so you can actually factor things out that aren't there. You just have to divide by that thing. So in the bottom, I want to factor out an x and get 5 minus, again, there's not an x for the 4, so 4 over x. And what happens? The x's here are going to cancel out. I'm just going to rewrite this. And then what happens to infinity when we plug infinity into these x's? Well, for 2 over x, changing 1 over x to 2 over x isn't going to change anything. We know that this is going to go to 0. All right, 2 divided by this really big number I'm plugging in is going to go to 0. Same thing for this piece, 4 over x. 4 divided by some really big number is going to give me some really small number, which is going to go to 0. All right, so those second pieces are basically worthless. They're both 0 as I get to infinity. So all that's left over is these numbers that aren't going to change, and my answer is just 3 over 5. All right, so this is kind of the strategy for finding horizontal asymptotes, is factoring out these powers of x, and then everything that has an x in the denominator is going to go to 0. So let's see it again. All right, in this example, I want to factor out the biggest power of x I can. So on the top, the biggest power of x is x squared. It's going to be 5. And again, the 1 doesn't have an x, so it's going to be 1 over x squared because I'm factoring out something that's not there. On the bottom, the biggest power of x is x to the 4th. I can factor out from the first term, the second term. It's going to be 1 over x to the 4th. All right, then I can cancel out some. In the last example, I can cancel out everything. I can cancel out some stuff here. At the top is just going to become this. At the bottom, I can cancel out 2 of the x's, so there's still going to be an x squared on the bottom. And again, I see what happens to these things as I plug in infinity. Anything that has an x in the bottom is basically going to become 0. So those 3 pieces are going to become 0. So this is the same as this limit. And again, I ask myself, well, there's an x still on the bottom here. All right, so this whole thing ends up being 0. All right, those things go away first. And then because there's still this x squared that's on the bottom, that still causes the whole thing to go to 0. All right, so in this case, we get 0. All right, we'll do it one more time and then look at the shortcut. All right, this one's the exact same problem, but flipped, so I can write the top half pretty quickly. Same thing with the bottom half. All right, it's the exact same from previous problem, just flipped. Oops. Again, we see what pieces are going to go to 0. These 2 pieces are going to go to 0 when x is going to infinity because there's an x in the denominator. And now we ask, what has happened if x goes to infinity? Well, this x squared is still on the top, and as we saw with polynomials, those just go to infinity. So here there's no leveling out because this x squared is just going to keep getting bigger and bigger. The whole thing goes to infinity. All right, so you might be able to kind of look back through the examples and see the pattern. All right, but here's the kind of... All right, so we're looking at the biggest power of x. So we had like one example, we had 3x over 5x. One example, we had x squared over x to the 4th. And one example, we had x 4th over x squared. All right, so if you look at the biggest power of x in your rational, if the numerator power is larger, so in this example, if the top power is larger, well, that means the top's not going to cancel and it's going to keep going off to infinity forever. All right, so right away from that last example, I see x to the 4th is bigger than x squared. I automatically know infinity or negative infinity is going to be the answer. And again, I just have to decide if it's going to be plus or minus. If the denominator power is bigger, so this is the second example. All right, the bottom power is bigger, then all the stuff on the top will cancel, and I'll just have something on the bottom. And if there's still something on the bottom, I'm going to get 0. All right, so right away in that second example, I know x to the 4th is bigger than x squared, and that's on the bottom, so I get 0. And then the kind of middle case is that the powers are exactly equal, like in our very first example. They basically cancel out, and I get left with those new coefficients in front, 3 over 5. So this is the kind of special case when they're exactly equal. You might actually get something that's a number rather than 0 or infinity. All right, so these are our horizontal asymptotes for rationals. All right, basically you're just looking at the highest power of x and going from there. All right, but remembering this whole factoring out x's is useful for some other examples. All right, but for now, this is a pretty good shortcut for finding horizontal asymptotes.